On behalf of Mr. J.D. Patil, President, Indian National Academy of Engineering, and Professor Manindra Agarwal, Director, IIT Kanpur, the co-chairs of the conclave, we extend a warm welcome to all of you at this valedictory session of the Engineers Conclave 2025, organized in association with IIT Kanpur. Over the past 2 days, we have witnessed remarkable deliberations, thought-provoking discussions, and inspiring ideas from some of the finest minds in engineering and technology. As we draw this enriching conclave to a close, it's a time to reflect on our collective learning, express our gratitude, and look ahead with renewed enthusiasm. I would now request Mr. J.D. Patil, President INAE, co-chair of the conclave, to kindly take his seat on the dais. I would now humbly request Professor Aditya K. Jagannatham, IIT Kanpur Faculty IIT Kanpur, coordinator of Theme 1, Intelligence System, to kindly step forward and be seated on the dais. Requesting Professor Santanu Chaudhary, Vice President INAE, coordinator of Theme 2, Interdisciplinary Cyber Physical Systems, to join us on the dais. Professor Jagannatham. I now humbly request Professor Nishchal Verma, convener of the Engineers Conclave 2025, to kindly step forward and be seated on the dais. I would now humbly request Professor Dr. P.S. Goel, FNAE, former President INAE, and Chairman, Valedictory Session, to kindly come forward and be seated on the dais. Ladies and gentlemen, please give a big round of applause for all our dignitaries. To begin with the proceedings of this valedictory session, may I now invite Mr. J.D. Patil, President INAE, to give the introductory remarks.
Engineers conclaves, to my mind, have always been a very learning kind of experience. There are few domains one knows of, but to sort of bring in the breadth and the depth across what all we discuss, and each of those engineering conclaves in the past actually have brought in different subjects, and that's essentially where what INAE does, we actually pick up those inputs. When we start talking of this particular EC, we see that there's two themes on which we debated. And if I have to sort of look at beyond those smart and the intelligent systems and the cyber physical systems, if I go into little next level of discussions, there's lot in terms of individual sessions which has gone in the domain of call it data, call it AI, call it smart systems, call it intelligent systems, or for that matter drones, or varieties of aerospace and related areas, and cyber security. Now, each and every of those, we had some amount of discussions in the previous session in collating those inputs that will go to INAE, and those coordinators for those two themes are here right on the dais. Those who were present in this hall have seen the kind of active interest the presidency of INAE takes, and Dr. Goel was here all through, and a lot of you would have seen that the kind of deeper thinking which people bring in, besides of course those who speak and do the needful. So this session is all about what we have really learned and what are those specific few things which we'll take away. And of course, if anything is missed out, now that this is everybody together, those two sessions now have merged. If there's anything that comes up, we'll do that part. With that, let me say thank you very much. Thank you IIT Kanpur for hosting all of us here. And of course, look forward to doing series of subsequent major programs at IIT Kanpur. Thank you so much. Jai Hind.
Thank you, sir. I would now request Professor Aditya K. Jagannatham, coordinator of Theme 1, to kindly present the summary of technical session on intelligent systems.
Thank you. Thank you very much, the dignitaries.
This will be not to focus on discussion,
Yeah.
only on recommendations.
The recommendations from the these things, right? Yeah, definitely. So Dr. Goel, Dr. Patil, Professor Nishal Verma, Professor Santanu Chaudhary, Head of the Department, Professor Yogesh Chauhan, for giving me this opportunity, and all my colleagues who are Professor Jalil Akhtar, Professor Patel, Professor Raghavendra, and Professor Nagarjuna, and Professor Ganeriwala, I think. All of my colleagues over here who have helped me this conclave. So thank you very much. And so I'm going to be summarizing theme 1. So theme 1 comprised of, as you know, I think we had a discussion. I think most of you have been here, also comprised of 4 sessions. I think very interesting. Really, the theme was intelligent systems, and brought together next generation communication networks, AI and data science, of course, drone technology, and cyber security, each of which is a vast field by itself. And of course, I am not an expert on any of them. My area is wireless communication, so I can talk a little bit about the first one. And I'll try to summarize the recommendations, etc., to the best possible extent in all of these areas. But if I misspeak or if there are any errors, I think many of the speakers are sitting here, so please feel to correct me, and so also the session chairs. So with that disclaimer, let me go on to, as I said, there are these are the 4 different sessions: next generation communication networks. What are the challenges and directions for future 6G? I think in communication, when you talk about the next thing on the horizon, the big thing on the horizon is very clear, that is 6G. And of course, with due respect to our other speaker, Professor Nilesh Mehta, was also highlighted that don't forget about Wi-Fi, right? So Wi-Fi is not lagging behind. So 6G and Wi-Fi, it's going to be a very interesting. So I think one of the recommendations that has come in terms of this session is that we have to take Wi-Fi seriously. That is, while we are focusing a lot on 6G, 6G might seem something like a game changer, and there's a lot of buzz around 6G. I think probably Wi-Fi is also not to be left behind. I think that's the overall policy recommendation. I think AI and data science, there are a lot of interesting recommendations. I think Professor Amrutur Bharadwaj, Professor Sangamitra Bandyopadhyay, and Professor Subrata Rakshit. I think what is very interesting is, if we start from the last one, Dr. Subrata Rakshit is staying over here, it's called for new levels or new modalities for standardization, ensuring reliability, because we have dealt with conventional engineering, we have dealt with software engineering. Now is the time to deal with AI, how to ensure standardization, calibration, reliability of AI. And from that perspective, and of course, Professor Amrutur Bharadwaj talked about engineering assistants and how these can enhance engineering education. You have biomedical applications by Professor Sangamitra. Coming next to drone technology, of course, we have the session chair, Professor Nishal Verma, and he had also summarized in our panel discussion. I think there is I think one of the key aspects of this session was that, of course, drone technology is going to be very important both for civilian and military applications. And I think Professor Dr. Somnath also participated very actively in that session. I think one of his key recommendations was also that we have to develop an entire drone ecosystem. That is, when we think about a drone, it's not just the drone, but there's a drone. The drone has it has navigation, it has sensors, it has a large number of systems and subsystems. So there has to be an entire ecosystem. There has an entire set of products which have to be manufactured in India to support this drone ecosystem. I'm not sure if I'm summarizing correctly, but I think that was one of the suggestions that has come from it. But it was very heartening to see, of course, there were 2 speakers from TSL and there was 1 speaker from National Aerospace Laboratories. So it's very heartening to see all the developments that are taking up, that are coming forth on drone development, and what are the possibilities and the potential. And of course, cyber security, of course, we have the session chair, Professor Soumitra Sanadia, and it's not my area, so I'll just try to summarize it to the best possible. But there's a lot of applications for as we go into more and more connected world, and more either intelligent or connected, or as we venture more into the cyberspace, be it either in automotive, be it either healthcare, or be it either in so many different areas. So a lot of interesting aspects of cybersecurity. For instance, cybersecurity for recommendations of cybersecurity for medical devices, policies of cybersecurity. There's an intense need to develop policies for cybersecurity and also for cybersecurity for automotive. I think that was what was brought in the last talk. So let me just go a little bit again into each of these things. I think the first talk highlighted the importance of 6G, right? And how 6G is on the horizon. What are the different applications for 6G, be it either near zero latency or digital twins, mission critical applications, and so on and so forth. Right, and therefore it is essential. I think the recommendations here are to develop unified and practical architectures, all right. Also integrate AI and ML capabilities with 6G. I think the other important recommendation here is that we are using the FR1, FR2 bands. FR1, of course, is the conventional sub-6 gigahertz, and we have the FR2. I think some of you might not come from a communication background. So just tell you a little bit about that. FR1 is the conventional, what we call as the 6 gigahertz and lower band, and FR2 is the 25 megahertz. And I think the new band that is coming up or that has been recommended is FR3, which is around the 2 gigahertz. I think that strikes a balance between the 25 gigahertz and the sub-6 gigahertz. I think if you go to the higher frequencies, the power losses, etc., are very higher, and if you go to the lower frequencies, of course, the bandwidth is limited. So I think the 7 gigahertz, the FR3 band is acts as a very good alternative, solves both of these problems, and of course providing very high bandwidth coverage with very low losses, right? So I think that's one of the important recommendations, that is to focus on newer bands, that is FR3, and of course also not to forget our classical technologies, that is of course what was fairly recent, but now the way technology is evolving, that is our massive MIMO and meter wave, etc. And the other recommendation here is to align ourselves with the standardized bodies. For instance, your 3GPP and ITU, etc., and of course, close collaboration between academy and industry. I think that is a theme of that is better need for improved collaboration between academy and industry to take these to the next level. I think the next talk focus specifically a little bit more on federated learning. I think this also ties into the next session.
So when we talk about AI and ML, AI, ML, and to what extent AI, ML can be used in wireless technology development. So I think this was an excellent talk which sort of spanned both the areas, AI, ML, as well as wireless technology. So federated learning, I think, is one of the areas where which can be used in this is a paradigm where devices can train collaboratively without sharing data. So you can have a base station, you can have a mobile station. I think you can train them with minimal exchange of information without exchanging all the data. So I think that is a very interesting perspective. So this is that these AI and the 6G and IoT networks need federated learning to enhance their capabilities for defense, smart cities, and other applications. And there are some hurdles in that, for instance, such as non-IID data and device heterogeneity and etc. and so on and so forth. So these need to be overcome to incorporate federated learning in the next generation communication systems. And also there has to be security again, which again ties into probably our last session, that is how do you talk about the security, differential privacy, blockchain style verification for our next generation systems. And also it talked about multi-tier federated learning architectures and defense academia prototyping to help deliver these federated learning algorithms in 6G. So in the next talk, I think that is where I was talking about. The next talk was very interesting in the sense it moved away from our conventional understanding of wireless technology or connectivity being focused entirely on, for instance, our with different generations of 4G, 5G, and 6G. While what we are realizing is that dominant fraction of the connectivity in today's world also comes from our Wi-Fi, right? So the idea is, Wi-Fi, the Wi-Fi can be a core 6G access pillar, so that can complement cellular. Like the speaker emphasized that cellular is for outdoor and coverage, while Wi-Fi is for indoor connectivity, and it can offload a lot of the pressure on your outdoor network. So there is a strong need for Wi-Fi evolution as the generation of cellular networks evolves. And also talked about the different technologies, for instance, the different access technologies, OFDMA, MU, MIMO, etc. And Wi-Fi 7, which is one of the things that is multi-link, and also the 4096 QAM, which is basically a high bit rate constellation that significantly increase your data rates because you're transmitting a large number of bits per symbol. So I think that is another interesting recommendation. And another very interesting recommendation that has come up from this is the full duplet, full duplet technology, which is, I think some of you, I think again there are many students, so some of you might realize we have what is called conventionally half duplet technology, right? A half duplet, and then you have either time division duplet, that is if the base station is transmitting to the mobile in one time slot, then the mobile is transmitting to the base station another time slot, or we have frequency division duplet. Now full duplet is a new technology where both the base station and the mobile can transmit to each other simultaneously, and that is an interesting thing that is catching a lot of traction. And there is a lot of course, the only challenge in that is self-interference. And it's interesting that this full duplet thing has come up, and whenever this full duplet has comes up, I cannot help but mention IIT Kanpur, because I think Professor Nilesh Mehta also knows the IIT Kanpur is the genesis of this full duplet technology, because the full duplet technology, I don't know if people have heard it, the first proof of concept or proof of action of this full duplet technology was provided by Dinesh Baradia, who is now professor at University of California, San Diego. And in fact, he was a BTech project student of Professor Ajit Chaturvedi, who was the session chair yesterday. So that is very interesting. And he's going to be here, interestingly, he's going to be here this weekend because he's been given a Distinguished Young Alumnus Award by IIT Kanpur. So that is another interesting thing. So he's going to be, whether full duplet technology is going to come or not, he's going to come over here this weekend. So that is something that is very interesting. So I think IIT Kanpur has a lot to do with some of these technologies, right? So that, of course, you can see that in my area I have definitely a lot more knowledge. So in the other areas, let me try to see AI data science. Of course, Professor Nishal Verma is an expert over here. I'm standing in front of him, so I'm a little bit nervous. Hope he does not mind if I make some errors. So of course, Professor Santanu Chaudhary is also here, not to make any, I hope I do not make any mistakes. So we have, I think one of the key recommendations here is Professor Amrutur Bharadwaj from IISc. I think very interesting recommendation is that the term I would like to carry out from his talk, of course, AI and data, AI ML, the first talk, the plenary talk by Professor PPC, I think that was very eye-opening, excellent, exceptionally good. And I think after that, I think most of us are now familiar to a large extent what AML is about, what AI ML is about, and what are the challenges. Right. I think one of the interesting things that has come up in Professor Amrutur Bharadwaj's talk especially is the concept of intelligence as a commodity, right? And that was very interesting. I've never seen that kind of thought process about intelligence before. So there are a lot of commodities that we've had. There are a lot of commodities, like bandwidth became a commodity maybe about 10-15 years ago, but now intelligence as a commodity. So can you go to market and buy some intelligence? What are the units going to be? How are you going to buy this intelligence? So that's a very, very interesting thing, and I think that can be a very good tagline for our future AI and development, unless he has patented it, I'm sure. I'm not sure if he has patented it. If it's not, I think we better patent it soon. So can intelligence be a commodity in the sense that can intelligence be bought on demand to handle these different tasks? And in particular, I think he had talked about two different applications. One is, yes. So I think that is one of his recommendations. That is, this intelligence as a commodity can use, for instance, as an engineering application. That is, can these AI-powered assistants be used for engineering applications, right? Can you use these? Can you use these assistants, or can you have these assistants which can now help us in these engineering applications? That is one. And the other is this AI-based teaching assistant. So can these teaching assistants now be developed and now can be probably procured and help significantly in our engineering education? So that is another interesting recommendation that has come up. And then the other one is, of course, develop a sovereign engineering AI framework. There's a framework that is specifically suited for the needs of our country, the needs, be it either the teaching needs, be it the engineering needs of our country, and etc. Let us look at the next aspect. The next aspect is biomedical research using artificial intelligence. For instance, it talked about the evolution of AI and GPU enabled and very different aspects of AI, such as your graph learning applications, etc., and so on and so forth. For instance, I think the speaker talked about several applications / recommendations. For instance, single cell RNA sequencing, multi-objective AI, etc. And I think one of the recommendations here or the emphasis here was about India's priority to build these indigenous biomedical data sets. All right. So this is that can form an EHR backbone and probably AI-ready health cards. I think there was also talk on developing a card similar to your Aadhaar card or something that can, at a particular number that can hold the entire health record of a particular person, and that can be integrated with various AI tools, etc. Right? So there's again another need. I think also advocated community level personalized medicine solutions and also scalability, affordability. And also a clinician AI policy collaboration. What is a policy? Development of policies for clinicians could collaborate or clinicians to use AI probability to ensure the highest quality, to ensure fairness, data quality, and research in medical AI in India. The third speaker was Dr. Subrata Rakshit, and of course his recommendation was very clear. That is basically it is a design paradigm, and of course, we have talked about, as I told you, there's conventional engineering design, there is software design, and now we are looking at design, AI design. So there is a need to develop urgent calibration standards, right? Requirements for development certification, labeled data sets, adequacy criteria, risk and model design, and also there has to be operational calibration data sets. So the urgent need to develop data sets for calibration of these you call it either AI assistants or AI models, etc. And of course, believability matrix, familiarity, competence, I think these are, and also I think finally recommended a calibration and certification framework that yields transparency and believability scores without, of course, exposing the IP of these companies, right? So this distinguishes this, and there's this significantly distinguishes it from the classical software as well as your classical engineering type development. So I think there is an immense need to develop this calibration and certification metrics, or you can say frameworks, etc. So we move on to the next session. That is, the next session was on drone technology, another very interesting area that was chaired by Professor G.M. Kamath, head of the aerospace department. Of course, the participants were Professor E.K. Ghosh and others. So one of the interesting things here was, first of all, it highlighted the indigenous UAV journey, how it began from a laboratory or began from the airstrip of IIT Kanpur and reached to a startup which was finally acquired by Tata Systems. And I think the recommendations here were very clear. The recommendations here were the future dominance in AI, dominance in drone technologies naturally hinges on AI, communication, and energy efficiency. So each of these, there were a set of recommendations of what are the technologies that need to be that need to develop to enhance AI and drone technology, communication for drones, and also energy efficient propulsion. So it called for, of course, again, I think there's an underlying theme, and it's an underlying sense that goes through all the themes, that there really is a need for increased collaboration between academia, startup, and these defense pipelines. All right. And also the speaker recommended a national mission to integrate R&D certification and rapid deployment of UAVs and counter UAVs. The next talk was Mr. Prashant Badoria from TSL. I think he talked about the various kind of drones, the various capabilities. For instance, what is the difference? There's a drone, different drones with have different capabilities, such as 24-hour endurance, 30,000 feet, and etc. 2250 to 300 kg, etc. And I think what this Dr. Prashant, Mr. Prashant was specifically focused on is certification for airborne software and an export interest in light manned ISR variant. And of course, again, there was a heavy emphasis on end-to-end Indianization, that is, be it either mission computers, high-value sensors, etc., or standardizing the AI and data fusion components for drones, and acceleration of this certification to meet the demands for the development of drone technology. And of course, the last talk was by Dr. Pashelkar, who was the director of the National NAL Bangalore. And I think one of his main key takeaways was how NAL can serve as to aid significantly in the development of drone technology, either for testing of drones, either for certification of drones, or either for serving as an aggregator for different kinds of drone components, etc. So I think there's a sense that the drone era is underway, and especially there's highlighting the NAL's high altitude pseudo satellites, etc. And reported also 1/3 scale prototype with full scale stratospheric vehicle, etc. And the talk specifically outlined shifts to swarms and multi-sensor fusion, pilot associate stack, and so on and so forth. And it also emphasized the need for AI in flight control and limited, well-trained envelopes with limited in reasoning, etc., and certification with human in loops design, etc., and how NAL essentially can act as a hub for the development of everything related to drone technology, be it either certification, testing, etc., and so on and so forth in India. And for that matter, of course, IIT Kanpur also offers itself as a hub for the development of drone technology with the various facilities, be it either your wind tunnel facility or your airstrip or so on with respect to payloads and so on and so forth. So I think there's a lot of interest in drones, and definitely there are a lot of hubs, and there's a need to develop more hubs for development of drones, be it either calibration, testing, etc. So these are some interesting policy recommendations. We come to the next session. That is, the next session is on cyber security. So the cyber security, I think there was also again a lot of interesting discussions happened over here and a lot of interesting recommendations. And so I think the first talk specifically focused on basically cyber security and cyber security applications and cyber security for medical devices. So there was essentially a need to push heavy security and lightweight authenticated encryption specifically for medical devices. I think there is identified several urgent R&D needs, including, I think, optimized message formats, energy-aware lightweight crypto algorithms, FPGA prototypes, rigorous test and verification, including a regulatory gap in India, and also the need for a new regulatory framework probably in India specifically with respect to cyber security in medical devices. The second talk by Ms. Kamini Malhotra, I think that the key recommendation here was to develop a set of policies for security, be it either for data provenance, that is to track where the data is originated, where data is being transferred, context-aware segmentation, formal methods in change control, be it either with respect to firewalls, SDN, etc., and continuously scan for conflicts, and also to engineer for disconnected or push policy caches and graceful degradation, etc. So I think there is a significant need to develop policies that meet the cyber security needs of today and the cyber security needs of the future. And coming to the last talk by Dr. Shashwat Raizada, I think the talk here focused predominantly on cyber security for automotive. I think that need here was also to develop a standard, unified security AI governance model and a standard that meets the cyber security needs, especially for vehicles and connected vehicles. I think so. There is modern vehicles are tightly coupled, and there are many external links, and making these these connectivity-driven vehicles are susceptible to attacks. Of course, right? There are a lot of links that make them susceptible to attacks. So there is a need for safe AI integration and ML-specific threat models and continuous verification, etc. And the speaker also recommended a compliance backbone with along the lines of ISO, SAE, and these different standards and preparedness for the EU CRA. I think that is, there are different global capability centers. So I think there's a need to also prepare for this European standards, etc. I think also another important takeaway was the operational hardening, the secure boot and signed OTA rollback, etc., and least privileged gateways and protocol-aware IDs, etc. So ultimately, the final recommendation was a uniform safety, security, AI governance that makes some of these cyber security, I think cyber security development, be it other cyber security development or I would say next generation cyber security possible, especially in connected vehicles. So I think that gives us, that completes my talk. So I think in order to summarize overall, I think we had, I would say, a very wonderful discussion, a very vibrant theme, intelligent systems, which brought together, I think, ideas, people, personalities, ideas from these different domains, be it either AI/ML, be it either next generation communication systems, be it either drones, cyber security. I think there's a lot of intelligent ideas, interesting recommendations. And I would also say there's a lot of synergies between these different sessions that was brought together. And There are several recommendations, and we look forward to preparing, of course, along with Team 2, we look forward to preparing a detailed report. I think we already have several ideas, several recommendations, etc., summaries, and we look forward to preparing a detailed report, and the same report, I believe, will be available openly and will also be submitted to the appropriate authorities. With that, I would once again like to thank INAE for giving me this opportunity. Everyone over here, Professor Yogesh Chauhan, head of the department, also one of the main organizers of this event. Thank you. Thank you very much, Professor Jitendra Bera, of course, and Professor Manindra Agarwal, our patron. So thank you very much, and thank you, audience, also for your patience, yesterday, today, attending all the sessions, participating actively, and keeping us engaged, being engaged, and of course, to our chief guest, Dr. Somnath, it's indeed a pleasure. It's a great honor. Thank you. Thank you very much. And thanks very much. I'll conclude with that. Thank you.
Thank you, sir. May I now request Professor Santanu Chaudhary, Vice President INAE, Coordinator of Theme 2, Interdisciplinary Cyber Physical Systems, to kindly present the summary.
Thank you for this opportunity to present the summary of the track 2. I think in presence of Dr. Somnath and other dignitaries and the leadership of INAE, it's really a momentous occasion for me personally at least. So I shall not provide the details of what happened in the sessions, but I shall try to, what we have done is an abstracted recommendation, and that's what I shall present. So if you look at, this is the core definition of cyber physical systems. I need not repeat it, but if you see the critical application domains covers energy, healthcare, robotics, mobility, industrial automation, agriculture, communication, transportation, defense, and security. So all these things together actually, if you see, represents a modern technology and industrial ecosystem. In fact, that's the significance of cyber physical systems, and with respect to that, what are the kind of recommendations these discussions really lead to? So if you see, these are some sample of technologies that were discussed during the sessions. These were, one was RF energy harvesting, which is interesting because RF energy is omnipresent. In fact, we don't realize, we talk about solar only, RF energy also omnipresent, and it also offers a technology challenge how to utilize and exploit. Then there were a few of these sensors, because sensors are really enable me to sense the environment, sense parameters for health, and gets connected to the systems to actually create applications around it. So there was also an accessible neurotechnology talk, which was very interesting in the sense that even in remote places, when there are brain stimulation and brain care can be provided, so that's the kind of a objective that talk really presented. Then there was robotics, which is human-robo partnership. And in fact, that's possibly given the population dividend of the country, we may not look at robotics per se, but cobotics to increase efficiency. Then Industry 4.0 and digital twin, which is actually transforming, in fact, industry as such. And we found a very nice presentation of from IIT Indore, how they had taken this up to transform MSME. In fact, today if you look at MSME, is the backbone of Indian economy. And anything done for them actually can have a transformative impact. So how the cyber physical system can play a role, that was talked about. Then agriculture as a cyber physical system and geospatial technologies was discussed later on. But there also, it's very, very important is that we are talking about geo-AI. The geography and AI coming together, it's completely a new perspective which provides us in terms of the development in areas like agriculture, like mining, like geological resource exploitation. So these are some of these key findings that we had in the individual sessions. So overall, what was the big picture emerged? If you look at it even with the presentation, earlier presentation as well, today we are living in a connected world, 5G, 6G, wireless, as well as satellite communication, and with respect to which we talked about geospatial intelligence. Then we have sensors, both sensing biological, chemical, and physical parameters. And these sensors connected over internet, that's the IoT, and that is linked with mobility and everything put together. If you see, sensing IoT and then connecting it back to the system, it's a closed loop system. And that's a closed loop system is what is cyber physical system, from physical to cyber back to physical. So here the key point is, therefore the bigger picture actually, if you look into it, today where industry is moving is Industry 4.0, where actually the traceability of the product and the traceability of the processes and quality control of processes are becoming critical. And that's where your cyber physical system, that sensing, monitoring, and AI can really make a change. And that's what I was talking about, how it can change the MSMEs. Then universal healthcare, this is actually a challenge in the country because someone in a remote hilly place actually may not have access to modern healthcare technologies, but the population has to serve. And that's where your technology, that communication technology and sensing and actuation can actually make really a change. So agriculture and food sustainability I already touched upon, and another very important thing which emerged is preservation of our culture and history. And with reference to that, digital technology has a role to play. And that's something which we should not forget. So therefore, there are huge opportunities. We have identified the opportunities where possibly the future research should be focused. One opportunity is industry IoT and smart manufacturing with Industry 4.0 in place. Then smart cities and infrastructure, because in India, large population is today city-centric. So catering to the city-centric population, improving the infrastructure of the city by introduction of technology and appropriate technology can have a transformative impact. Then therefore, healthcare and agriculture, the other two things I've already touched upon. And if you see defense and national security, the development of CPS technologies for autonomous systems, surveillance, and cyber defense to enhance national security capabilities is, I think, even with DRDO discussions, this was very apparent and clear. Energy sustainability. In fact, energy is all through whatever we are talking about, energy is a key point. And there are energy, and we have to develop sustainable eco-friendly solutions with a human in the loop. So we are talking about cyber physical system, but the whole discussions, the way the things went forward, we are actually moving towards cyber physical human system. Taking into account Indian context, we possibly should not talk about only automation, but to make things happen with human in the loop. Therefore, these appropriate technology, demand-driven, these are actually the issues of appropriate technology. It's not just a technology which is state-of-the-art, but appropriate technology with reference to Indian data, and flexible technology which is adaptable to local situations and demands. So the whole perspective of technology development changes. And if you look at the cyber physical system and why, and with AI in place, these technologies really become adaptive and adaptable. I think that transformation is something very, very critical with respect to what we talked about today. So we need a non-conventional approach and innovation from unconventional technology spaces. This is the open area for the Indian scientific community really to get into and create an impact. So observations that if you see today, this AI brings intelligence and adaptability to cyber physical systems, and machine learning plays a key role in making the system smart. So technology trend shows a closer integration of AI and cyber physical systems. In fact, these technology engineering conclave has actually highlighted this data and perfectly aligned to the requirement of this integration. Engineering application of AI is a major thing which is emerging, and that we cannot ignore without integrating AI into cyber physical systems. So another thing is return of investment. I think all we talk about, but the return of investment is something very, very important when you talk about technology development. So innovative design of products and systems with a system level thinking and addressing needs of the people is a way to exploit and explore new markets. Without that, the technology innovation will not really go anywhere. It will remain confined into the papers and the publications. So startup ecosystem and rejuvenating MSME is really important, and also important for the engineers to think about new business models. It's not only a management task, because engineering perspective gives a different indications and different objectives to look at the business. So this is something which actually engineering community should really be concerned with, that novelty in terms of business model is an open space which is integrated with the emerging technology. So therefore, deep-rooted objective and pursuit of research and technology targets and consistent investment is important required. The ever-increasing bureaucratic hurdles in executing research and translation projects came up number of times. And this is something important, and this is a phrase I got to one of the presenter, that master-slave relationship between funding agency and PI should be stopped. Okay, so this was, it resonated with my thoughts, and I thought I should indicate it here, because it's a more open forum to talk about these things. So action point is greater and continued thrust on mission mode technology development project on AI-based cyber physical system to exploit AI for people-centric engineering and social problems. And possibly, INAE can take an initiative to create a research-cum-innovation fund with contributions from government and industry, boost to industry, startup, academia, research organizations to get more engaged in this area. And getting engaged in this area is something very critical and important for India's economic and technology development and becoming a technology and economic superpower. Thank you.
Thank you, sir. I would now like to request Dr. P.S. Goel, FNAE and former President INAE, and Chairman Valedictory Session to kindly deliver the valedictory address.
Good afternoon to you. Dr. Patil, my colleagues at the dais, and also very senior people from the front rows. Our chief guest of this function, Dr. Somnath, and students. You have heard gist of everything, and we have been hearing for the last 2 days. INAE Engineers Conclave is slightly different from other conferences. The concept is that we must be looking for the future and try to solve the problem before they appear. And this is one exercise in that direction. And I think we have largely succeeded in that direction. You have heard the recommendations. Only thing is we have to do a little sharpening. We have to really say what we want to tell, let's say, the Department of Science and Technology, what we want to say the biotechnology, what we want to the Agriculture Ministry, or what we want to the PMO, or maybe Education Minister, so that he can do to the education. So we have to segment it and make it actionable. That word actionable is very important. And I'm sure the INAE and our colleagues at IIT Kanpur will really put into that framework. Now, engineers are important. Do you agree? I never felt so till I visited Netherlands. There was a conference, and actually it is a body of CASE, body of academies of engineering of the whole world, 28 of them. The mayor of Amsterdam in the evening, he came and he asked us a question. He said, I'm laying down the pipeline for drainage for Amsterdam. It should last for 50 years. Can you tell me, what will happen in 50 years with respect to climate change, so that I don't have to change in between this drainage line? It should serve for 50 years. And I was wondering that in our country, we don't even plan for today, we plan for yesterday. And he's planning for 50 years later. But then simultaneously he said he has got very high respect for engineers. And he said that Netherlands exists because of engineers. The airport in Amsterdam is actually 100 feet below the sea level. And there, first time I felt that, look, this is what engineers should earn. And this is where we felt that we should really bring INAE to this level. You know, we have 3 science academies in the country. We have many other bodies for agriculture, for metallurgy, for medicine and all that. INAE has to be different. And the main difference of INAE was that we should serve the society and give the solution before they occur. And this is one exercise in that direction. I have been visiting the government of India, particularly Modi's government, for last 10, 11 years. And my impression was that he has got very little faith or confidence in Indian science and technology. And I was convinced about it. Till the Operation Sindoor. You see a sea change in his attitude towards engineering, towards sciences after this operation. Why? Because, you know, when we are talking of war of today is not man to man. It's not like what used to happen 50 years back or 100 years back, not like World War I or World War II. Today's war is actually more and more non-contact war. When you say more and more non-contact means what? That means it is the technology that is fighting the war. And if technology fighting, who is the responsible for technology? It's engineers. And first time probably he realized, if you really see Operation Sindoor and analyze that, I did one exercise. There are at least 15 different technologies. They have been used in those 2 days, and they have made all the difference. In fact, I was giving a talk in INAE once, just about 2 months back, trying to see who are the people. And you will be surprised. I'll just give 1 or 2 examples to you. See, when we talk of BrahMos, where from BrahMos came? It was one person's thought. He thought that if we can combine with Russia, because he used to be often going for Russia for different purposes, then we can make this missile together, because we have all of the technology except we didn't have the so-called hypersonic engine. So he proposed that and joined with Russians. So it's called actually BrahMos, I think, our 2 rivers. One is Moscow River, another is our Brahmaputra. BrahMos comes from that. So there's one person behind it. I won't name right now. There's another person who has spent his lifetime only on Akash. Actually, he started work in late 70s and retired. And actually, the result has come only after so many years. Akash made a hell of a difference. There is one person, again, and I can be open here, which has not been publicized much. He has such a huge capability. All of you have got a telephone, mobile today. He can make you feel, if you go to Google, as if you are sitting in Delhi. All of you will see the mobile and will see this is Delhi. He has that capability. Now you imagine if a missile is coming and you can fool a missile that, okay, rather than coming to Delhi, and he makes it appear as some other village 10 kilometers, the missile is useless. So such technologies have been used for the first time in the world, some of them. And that's why the Operation Sindoor was so successful. And this is first time probably, I feel so, that our Prime Minister realized that, look, engineers or scientists are important. Now this realization actually we should capitalize. And also we should also see that, okay, one is of course, it gives us, all of engineers pride that, look, we have been useful to this country even in terms of war. Of course, we have been useful in terms of food, we have been useful in terms of the IT, all that is known. But even in the war, we can make such a difference. So this, why I'm giving this thought is that engineers have to have a role which is quite different than, and particularly INAE is very different today than any of our such associations, such academies. And my wish as a past president is that particular exercise, that particular relevance to the country, that particular thinking that yes, we will solve the problems of the country before they appear. With that message, I feel that this is the message has to go to all younger people, all students, and all of us. With that, I would like to close my thoughts to you. Please continue to thought that you are important for the nation. Thank you.
Thank you, sir. Moving forward, we now begin the felicitation ceremony. I would like to invite Dr. P.S. Goel to kindly felicitate Professor Aditya K. Jagannatham, coordinator of Theme 1. Gratitude reflects the noblest character and aspect of our culture. On this note of thankfulness, may I request Professor Nishchal Verma to kindly propose the vote of thanks, acknowledging everyone who contributed to the success of this conclave.
Distinguished dignitaries on and off the dais, esteemed guests, faculty colleagues, industry leaders, research professionals, participants, volunteers, students, fellow engineers, and ladies and gentlemen. As the convener of the Engineers Conclave 2025, hosted this year by the Indian Institute of Technology, Kanpur, in collaboration with Indian National Academy of Engineers, INAE, it is my singular honor and privilege to deliver vote of thanks at the conclusion of this remarkable gathering. We are deeply grateful to Dr. Somanath, who is present here, our esteemed chief guest, for gracing the conclave with his presence and insights. Thank you, sir. I extend heartfelt thanks to Professor Manindra Agrawal, our director of IIT Kanpur, and Mr. J.D. Patil, president of INAE, for serving as co-chairs and guiding the event with their leadership. Thank you, sir. A special note of appreciation to my colleagues at IIT Kanpur, Professor Jitendra Bera, Dean of Faculty Affairs, IIT Kanpur, and Professor Yogesh Chauhan, Head of the Department of Electrical Engineering at IIT Kanpur, for their overall coordination. I also thank the advisory constituting Professor Jayant Singh, Professor Khantesh Balani, Professor Siddharth Panda, and Professor Y.M. Joshi for their all possible support. I would also like to thank our organizing team members, Professor Jalil Akhtar, Professor Aditya K. Jagannatham, Professor Kantesh Balani, Professor Raghavendra Chaudhary, Professor Nagarjuna Nallam, Professor Abhilash Patel, and Professor Mohit Ganeriwala for their tireless efforts and valuable contributions. I now request Mr. J.D. Patil, President INAE, to kindly felicitate our organizing team for playing a key role in organizing the event. I would now invite Professor Jalil Akhtar to please come on stage. Professor Raghavendra Chaudhary, Professor Nagarjuna Nallam, Professor Nagarjuna, Professor Abhilash, please come on stage. I would also like to thank Mr. Vijay Shukla and his entire team from Electrical Engineering Office for their help. The academic environment, administrative support, and impeccable arrangements at IIT Kanpur provided an inspiring backdrop for this year's event. The energy, enthusiasm, and commitment of our faculty colleagues, staff, research scholars, and student volunteers have been truly commendable. A heartfelt shout out to volunteers, Abhisha, Ruby, Aditi, Shubham, Saurav, Tilak Dhari, Dr. Anubhav, Prakriti, Ashlesha, Anushuya, Shreya, Akshay, Akiv, Sanbor, Arif, Vikas, Pooja, Dr. Sanjeev, Insha, Neelam, Lisa, Atinav, Pradeep, Ritik, Aman, Aditya, Ishan, Dhananjay, Pradeep, and Harsh for overseeing overall arrangements. We extend sincere thanks to our sponsors and industry partners, Keysight, Agmotel, and IEEE UP section for their generous support and collaboration. IEEE UP section chairperson, Professor Yogesh Chauhan is present over here. Your contributions enabled the seamless execution of this event and reinforced the essential synergy between academia, research, and industry, the cornerstone of innovation-led growth. Our deepest appreciation to the theme coordinators, Professor Shantanu Chaudhary, Vice President INAE, Professor Aditya Jagannatham, and Professor Jalil Akhtar, for curating expert panels and facilitating insightful deliberations. I also thank Dr. Mishra and Dr. Goel, former presidents of INAE, for chairing the plenary sessions, along with the esteemed session chairs and distinguished speakers across 4 panel sessions for their thought-provoking contributions. Thank you, sir. We are grateful to the INAE leadership, President, Vice President, Council members, and fellows for their unwavering guidance and vision. Your commitment to advancing engineering excellence continues to inspire us all. A special word of thanks to the INAE organizing team, Colonel Rai. Can you please stand up? Thank you, thank you, thank you. Ms. Pratigya Laur, Colonel Sharma, Dr. Chanchal Moni, Mr. Seetal Sharma, Mr. Rakesh, Mr. Piyush, and all those who were working behind the scenes. Your meticulous planning and seamless coordination were the backbones of this successful event. Finally, to all the delegates, participants who joined us from across the country and abroad, thank you for your active engagement and meaningful contributions. Your presence transformed this conclave into a vibrant celebrations of engineering excellence and collaboration. As we conclude Engineers Conclave 2025, let us carry forward the ideas, partnerships, and inspiration it has generated. May we continue to work together towards innovation, sustainability, and societal progress through engineering. So with these words, now the Engineers Conclave 2025 is being declared as closed.